Hi, this is Jeff Coronado from JCSE, and this is Bridging the Gap. So it's an ongoing sequence of structural engineering design tutorials that we have here at JCSE. Um, and this one in particular, we're tackling a question that's kind of come up that basically, to encapsulate the question, it's how are loads combined using load combinations? And it's actually a fair question. So let's kind of jump into this. For now, we're not going to touch too much in this tutorial on an explanation of the individual loads, dead load, live load, wind load, all of the other loads that are covered in different codes. Some of those are actually explained in other sessions of Bridging the Gap. So you can either try to search for those or on the channel, or feel free to leave a message in one of these, and we'll try to pick it up and point you in the right direction. Or if you have a specific question, by all means, send the question in at the end of this tutorial, and we'll try to point you in the right direction. But anyway, let's assume that you have familiarity with the individual loads. Really what we're getting at in this tutorial is combining those loads. So let's scroll down here. So how do we combine effects of loads? And I kind of throw it out there. Do we use the ACI 318 load combinations? Do we use the AISC 360 load combinations? So I think for especially younger engineers who are coming out of school, that might very well be the answer that you would give. If you're currently in school or you have been out of school very recently, that's probably the answer that you would give. Here's what you need to know, start to understand. ACI 318 and AISC, the different codes or standards, I should say, by the different trades, meaning concrete, steel, masonry, timber. Those standards do not represent legal documents. They are not what you are legally obligated to design for. So those are not the load combinations that you should be looking at per se. In many states in the United States, the legal code, what is the legal code, is the IBC. That is what is adopted as by the legislature in the state as the legal building code. So if that is the case, then those are the load combinations that you need to comply with, the IBC. Now, for instance, if the IBC were to say you need to follow the load combinations in ACI, okay, then you follow the load combinations in ACI. But it has to come from the document that is the legally adopted document in your particular state. So be real aware of what your legal document is for your jurisdiction. It could be the IBC. In many states, the states will adopt their own code, or it may be a modification of the IBC. So if you're in Florida, if you're in California, there's a multiple states that have their own building codes. You just need to know what's the code that is legally adopted in the jurisdiction that you're in. That said, some cities and counties have their own codes. So if that's the case and that's the jurisdiction you're in, you need to be aware of that. And then any load combinations that are prescribed in those building codes, then that becomes what you need to comply with. Now, I believe as far as the myriad of codes, there's another tutorial session in Bridging the Gap. So if you have a question on that, by all means, leave a note at the end of this tutorial, and we'll try to point you in the right direction. Okay, I apologize. I had to step away for a minute. Let me see. Where did we leave off here? I think so. We're discussing about how legally what you are required to comply with is the code that's adopted by your legal jurisdiction, and I think we amply discuss state. However, even cities and counties sometimes can have codes that are legally adopted for that city or that county, and so you need to be aware of that and comply with that. Sometimes there's even other jurisdictions, so that becomes on a case by case basis. Usually on that project, you will know if there is even a different code or set of load combinations that you have to follow. But for those of you again that are in school or have been shortly out of school, have recently gotten out of school. I know that the go-to tends to be the ACI load combinations, the ACI 530, ACI 318 load combinations, AISC combinations, and those are not the ones that are legally enforced. So be cognizant of that. Okay, so once we've determined what jurisdiction we need to comply with, the other key question is, are we doing ultimate strength or allowable stress design? So two procedures that you can follow. In large part, that's dictated by the material that you are working with, but that's again a matter for another tutorial. If you have a question on some of those bridging the gap sessions, bridging the gap tutorials, again, leave a note at the end of this tutorial session, and we'll try to point you in the right direction. So as an example, just as an example of combining loads, we're going to first look at a load combination that's present in the CBC, which stands for the California Building Code. So California is one of those states that has its own code, its own building code. So we're going to look at the California Building Code, and we're going to look at a load combination in the allowable stress design section. So allowable stress design in the California Building Code is covered in section 1605.3. So that is the section that shows all of the different load combinations that you have to comply with in California. The very first one of those is equation 16.9, and that stipulates a combination that combines dead load and fluid load with the factors, load factors of basically 1.0 for each one. So 1 times the dead load plus 1 times the fluid load is what this equation is telling us. So with that, first let's focus on D. And you know what? Let me stop here for a second. Let me stop. Okay, so I took a moment to draw this out. Basically, what we've got, what we're trying to do here is switch over. Okay, so here's the ground. Here we've got a base, right? So the black is a base that supports this water tank. All right, so we've got a water tank, and oops, sorry. We've got a water tank, and it is filled with water. So as far as D is concerned, the dead load in this, I think it's fairly intuitive, right? Dead load basically represents gosh, I don't want to say always, but when is dead load not going to be just a force that acts downward, right? The dead load is going to be, let's say, depending on how you look at it, it's going to be the force that acts down from the soil, induced on the soil from this base. It's going to be, you know what? Let me make this even simpler. Let's not worry about the base. Let's not worry about the tank. All right, let's just say the dead load, let's just say we're going to look at the fluid. All right, so this fluid is what we're taking into consideration. All right, so the dead load is the force acting down, by the fluid on the different elements that resist, that support it. All right, that's the dead load. It's the weight. It's the weight of the fluid acting downward. Let me erase. Let me just erase this. Let me see if I can scroll down. Um, yeah, let me keep the same sketch here. So, so we've looked at D. Now let's look at F. What direction does the force F act in? Well, I think the fairly obvious answer is, actually, no, it may not be obvious. It may not be obvious. Because after all, what's obvious to one person may not be obvious to another person. But so what we have, F, is a lateral force. Sorry, shouldn't have done that. So it's a lateral force that pushes out on the tank from the fluid that's inside of the tank. So any fluid that's inside the tank is going to create a horizontal lateral thrust pushing out of the walls of the tank. So I'm showing an arrow here going from left to right. The same thing would apply on the wall on the left. It would apply to on the walls all around this tank. The fluid exerts an outward pressure on the walls of the tank. So F becomes a lateral force on the structure that supports it, in this case, the tank. Now, how to determine F, that's covered in another session, in another tutorial session in Bridging the Gap. So again, you can leave a note at the end of this session, and we'll try to point you in the right direction on that. Now, just for purposes of a numerical example, let's just say hypothetically, we say that the dead load, meaning the dead load, let's say the dead load, which would be the weight of the tank, all right? So, and that's what we're showing here with the magenta arrow. The dead load is 100 pounds. Let's just say that F sub H, so that would be this force, right? The horizontal thrust created by the fluid, F sub H. So let me, F sub H is 200 pounds, and F sub V, so F sub V becomes, go back to magenta again. So F sub V, right, the vertical component of the fluid force is 300 pounds. Again, these numbers are just hypothetical. I don't know if they even make sense or not. Again, the fluids, I think, are covered in another tutorial. So you can leave us a message after this if you'd like us to point you in that direction. But for purposes of this example, let's just say that the horizontal thrust from the fluid is 200 pounds and the vertical thrust from the fluid is 300 pounds. Okay, so now let's revisit the load combination that we were looking at initially. Remember, that load combination was D plus F. So the question is, what does D plus F mean? Is it literally a numerical addition of those numbers? Do we add D plus F? Is that what the code is trying to tell us to do? So if that were the case, would the answer be 100 plus 200 plus 300? That's D plus F, right? Or does D plus F mean 100 plus 200? Does it mean 100 plus 300? So really what we're getting at is the load combination, when we look at load combinations, is it simply a numerical addition of those forces, or is it a conceptual combination is it a conceptual addition of the load effects from those loads? Is it the addition of the load effects due to dead load and the load effects due to fluid? As you might guess, that's the correct answer. It's the load effects that we are combining, not just the numerical addition of those. So no, the correct answer would not be A. It would not be 100 plus 200 plus 300. After all, that would have no meaning, right? 100 is a force that acts downward. 200 is a force that acts horizontally. And 300 again is a force that acts downward. No, we wouldn't want to be adding forces that act the magnitude of forces that act downward and horizontally. It's almost like going back to what, first semester school, or first freshman year school, where we were covering physics, right? Or maybe even high school physics. No, we're not adding magnitudes, right? We would be adding vectors. And no, you're not going to add a magnitude of a vector that's pointing to the right and the magnitude of a vector that's pointing down, and you know, there would be no logic in that. So what we need to look for is combining the load effects, right, combining the load effects. So let's just say we were designing the wall of this tank. Well, this load combination of D plus F, in essence, D would probably default to 0. Well, unless you need to take into account the self-weight of the tank. But that gets us into another situation there. So let's just say, for simplicity, that the wall of the tank would be combined for the lateral thrust from F sub H. However, if we were looking at the pedestal, at this pedestal, then the load combination D plus F would give us a vertically downward acting force of D, which would be the 100, and the vertical acting downward load of F sub H, which would be 200. Right, so you're almost doing a vectorial combination, not just a magnitude combination. If the forces from those effects line up, if they're acting in the same direction, then yes, you would combine them. But if they're acting in different directions, no, you're not just adding the magnitudes. Think about the effects. You're combining the load effects. So when the building code says, let's say the load combination stipulates D plus F, don't just think about adding the magnitude of D plus F. I'm not saying that's not always going to be the case. In some cases, it will be a simple straight addition. But think more of the effects due to dead load and the effects due to fluid load that you then need to combine. See how those forces act, in what directions they act, and then see about combining those effects, not just straight across a combination of magnitude of forces. All right, hopefully that's clear. If it isn't, if you have any questions, by all means, leave them at the end of this tutorial and we'll try to get to it. So with that, let me clear the screen here. And yeah, if this helped you, sure would appreciate if you leave us a thumbs up. If you want to leave us any comments that might make these more helpful for you, these tutorial sessions, by all means, feel free to make any suggestions. And if you, let me see, where is that? Okay, I'm sorry, got taken away, but basically I think we had concluded this. Yeah, if you feel free to follow our channel if you enjoyed this tutorial, and it helps with bridging the gap in your understanding of structural engineering design. Okay, real good. Thank you.